Okay, the first algorithm we're going to talk about is the breadth. Okay, let's just get rid of that. Let me just start all over again. Okay, it's the breadth first search algorithm. Now, it's one of the basic algorithm for searching, and I'm going to explain this algorithm with an example. Okay, so let's draw a tree structure to explain this algorithm. So let's say I got a start node A and two of its child nodes are B and C. Let's draw another node D and E. So another F and G for as child nodes for C. And also draw further for E, F, G. All these would be the child nodes. Okay. So let me just tidy it up a bit. So let's just okay. Now let's draw that for child nodes for D, E, F, G. Okay, that would be H, I, J, K, L, M, N, O. Okay, so our structure is pretty much there. The few things we need to establish before we start is where we're going to place our output of uh, the path that we're going to traverse. Okay, and we're also going to use a data structure Q in this algorithm. Okay, so Q is a data structure that is used in many scenarios. You could think of Q basically as um, a, a queue, really. If, for example, if you go to McDonald's to get a burger, if you go first on the counter, you will be served first, and whoever is going to come behind you, they have to wait until you are served. So essentially, that's what the queue is. And placing something on the queue is called enqueuing. And if somebody is served, they will come out of the queue, and that is dequeuing. Okay, so let's make a start. So we're going to start with our node A, and oops, let me just get rid of that. Okay, so we're going to start with node A, and we're going to put that A on our result, which will give us the path that we're going to traverse in this structure, in this tree structure. So because we are starting with A, we put A on our queue, and we will make the node A as visited with these little dash lines in there. And as we are the A is the first node on the queue, and that will also tell us where we are when we are traversing in our structure. So it's like a pointer that will tell us where we are in this structure. So at the moment we are at node A. Okay, the next thing we need to check is, are there any unvisited nodes from A? In this case, we got node B and C, which are still unvisited. So we're going to go through alphabetical order. So next node in line would be node B. We'll output that and make it visited. If we make this node visited, we will put this node on the queue. Okay. Now, as we are on still on A because our pointer is pointing to A. Right, and we're going to check again whether is there any other node which is not visited from A. Right, so C node A is the one which is still not visited directly from A, so we're going to output C, make it visited, put it in Q. Okay, now A node is pretty much served now, so what we're going to do, we're going to get rid A or dequeue A from our queue in this way, and the pointer now would move from A to B. Okay, so what we're going to do, we're going to change the pointer and we'll change it to node B, and we need to repeat the same process for node B as well. Okay, so it's interesting to watch how the algorithm will be traversed. So it's like we would traverse from first level and then traverse to the next level, and then we're going to traverse on this level and then the bottom level there. Okay, so it's going to sweep this level first, second level is going to see all the nodes in the second level, and third, and as we go further. Okay, let me just get rid of that. Okay, so that's why we call breadth first search, because it goes and traverses in breadth as compared to depth. Right, okay, so we are at node B and we're going to check are there any nodes from node B which are unvisited, in this case D and E. So we're going to start with D, put D on in our list of the nodes which we will traverse. So we will make D as visited. We already visited now, put that node in our queue, and we'll check again from B because the pointer is still at B, and we will look at we could see E node is yet visited, make it visited, put it on the queue, and B is served now. Now, if the B is served, all we need to do then, we need to dequeue B from our queue, change the pointer to the next element in our queue, which is in this case C. So we will go C, and you could see it's traversing in breadth. So we're starting from top node, went to the B, and now we're going to C. Now in C, we will again check are there any unvisited nodes. In this case, it's F. We'll make F node as visited, and then put that F node in the queue. And what we'll do, we will also check is there any other node which is not visited. In this case, it's G. So we'll put on our output path, make it visited, and put that in our queue. And we'll do the same process for next level, but as C is all served, what we'll do, we'll dequeue C and get rid of that and change the pointer from D to from C to D. Okay, that's the next in line. So point, now we are at D. Again, repeat the same process. In this case, make H visited, put it in our path, and again put H in our queue. Then same again, H I, make I visited, put it in the queue, and D is done. So we're going to dequeue D, which we will in this case, and the next in line is E, as you can see, and make the pointer to E. Okay, we have two unvisited nodes which are J. J in our queue and make it visited, and then the next one is K, put it on output path, make it visited. K will go in queue, and E is pretty much served. Okay, so what we going to do then, remember this is still our queue. Okay, all of this is, we are generating our queue here. So we were at E is served now, so we're going to dequeue E from our queue and change the pointer to the next element in the line, which is F. So let's draw that. Now F still got two unvisited nodes. In this case, the first one is L. Make it visited. So make L visited. Put it in the queue. And the next one is M. Make it visited. Put the path in the queue. Okay, so F is served now. So what we'll do, we'll dequeue F, and next in line would be is T. Okay, so the pointer will go to T. And again, make N on our path, make it visited, put it in Q, and similarly O, make it visited, go in the queue, and now G is served. So we're going to get rid G from our queue. The pointer will go to H. So now H is already been visited, and there are no unvisited nodes from H. So H could be served. So served. So we'll change the pointer to I. Okay. And then we look at I. No unvisited node from I. So what we need to do, we will dequeue I from our queue. Pointer will go to the next element in our queue, which is J. So let's point it there. Again, from J, there's nothing to be visited. There are no unvisited nodes. So we would get rid of J. And similarly, we'll get rid of K because there are no unvisited nodes that are going out from K. So we'll move on to L, DQL, M, N, and O, and when we come back to Q is empty, and this is where our algorithm will stop. It means it has traversed through the whole structure. Now, if you would have put a condition such as if F is a goal node, then as soon as we hit F, then we would have found our node that we wanted to find. Okay. I hope it's helpful, and I'll be explaining with further examples these concepts. Okay. See you again.